In this video, we are going to discuss the various types of system calls available in operating systems. Let's recall that in the last video, we discussed about how the system calls are essentially an interface via which the user or user applications can interact with the different functionalities that are provided by the operating system. Now, in this video, we are going to discuss about the different types of system calls. Now, as we know, there are these different types of operating systems. We have Windows, we have Linux. On a very high level, we can say that similar system calls are available in different types of these operating systems. There are 6 different categories in which we have tried to classify the types of system calls. Although each of these different operating systems have similar system calls, they are available under different names. For example, the fork system call that is used to create a process in Linux is called as create process system call in the Windows operating system. In this video, although we do want to learn the different types of system calls, a very high level motivation can be to also try to understand in a little more depth as to the different functionalities provided by the different system calls, because this is going to help us understand the functionalities of an operating system as well. Because like I said, the system calls are essentially an interface to the operating system's kernel. Okay, so the first category of system calls are the ones that enable us to control the different processes running on the operating system. Like I said, the fork system call or the create process system call can be used to create a new process. This can also be used to create multiple parallel processes as well. We will discuss this in more detail in the upcoming videos. Once a process is created, we would want to load some set of instructions or a program that we expect that process to execute. That can be achieved via the load system call. And finally, once the program has been loaded into memory, we would like to execute the process, which can be achieved via the execute system call. While the process is executing, it may want to wait on certain events, waiting on an input from the keyboard or waiting for another process to finish. Or we can also wait for a certain amount of time, like few seconds, where the process would halt its execution for that much amount of a time. The signal system call can be used to signal the completion of an event. Next, there are 2 system calls, end and abort, that are used to signal the termination of a process, wherein end system call signifies that the process terminated normally or successfully, whereas the abort system call signifies that there was some interruption or error due to which the process had to terminate. Then we have some system calls for file management, wherein there are different system calls available to create a new file or a new directory, then open a new file, read the file, write to the file. Once we are done, then close the file or delete the file as required. There are also some system calls that enable us to get some file attributes or set some file attributes. These attributes are essentially the metadata that is associated with the files. I again want to highlight that although I have mentioned the names of these system calls as create, open, read, write, and so on, but they are mentioned under different names within different operating systems. Next, we have system calls for device management. Before that, let's try to understand what is a device. Device obviously includes input-output devices like keyboard, printer, even the hard disk is a device. So we should develop our thinking on that level, that if a process wants to, let's say, write to a disk, it would need to use the device management system calls. And similarly, if a process wants to do some input-output work, it needs to use the device management system calls, which are request, which is to request a device, because devices are shared resources and can be accessed by single or limited number of processes at any given time. Once you get access to the device, you can read from the device or you can write to the device. And once you are done, you can release the device. Then we have information maintenance related system calls. This information essentially refers to the system information or some processes related informations. System information, like if you want to get the current time or the current date, processes related system calls, like if you want to get the PID or the process ID of a process, you can use the get PID system call. And then there is a dump system call, which essentially captures the memory snapshot of a process at any given time and store it in, for example, a log file, which can later be used for debugging the process. Next, we have communication related system calls. Communication could mean inter-process communication, wherein two processes are trying to communicate with each other. We have a complete set of videos in this course that is going to be dedicated to inter-process communication. But for now, on a very high level, one way for two processes to communicate is to pass messages. Now, to facilitate passing of messages, you would first need to have the two processes connected, and then the processes can use the read-write system calls to communicate or to pass messages, and then finally close the connection when required. The second method for process communication is via shared memory, where you basically allocate a memory location. Both of the processes can read or write from the same memory location. SHM get and SHM at or SHM attach are two system calls that help in setting up the shared memory. Lastly, there are system calls to help with protection of the system or the system resources. So we can assign or fetch permissions to the different system resources, for example, to different files, based on which the users will be allowed or denied access to the file. Now that we have discussed the different types of system calls, I again want to highlight what I mentioned at the start of the video, that the motivation of this video is not just to understand the types of the system calls, but also being able to imagine how these system calls are actually providing an interface to the different operations that are supported by the operating system's kernel. And this helps us set up a foundation for the rest of this course, where we are going to discuss the kernel in much more detail. See you in the next video.